Okally dokally. Which angle has a different reference angle than all the others? A. You don't know why it's one of the answers I circle. What should you do? Ask. Does anybody wish to ask? Excellent. What about number 2? A again. What about number 3? C. What about number 4? Oh, yeah, okay. So, where's 150? Out here, yes? Which makes this 30, yes? Which makes this a 30, 60, 90 triangle, yes? Which makes 1 across from 30, 2 is the hypotenuse, and negative root 3 is the adjacent. Cos of that is x over hypotenuse, negative root 3 over 2. Yeah? All right. I expect you all, this is a significantly big hint. I would expect you to listen very closely. I would expect you all to have that and that memorized and everything that means. Okay? Hint, hint. Number 4. I have a B. B is what we're going with? B is correct. You guys are so soft. Be strong. No, I said B, and then I paused, and I listened to Crystal's breath. And when it got to, then I told her it was the right answer. And then she said, oh. What should it have been? B. And then I say B, and she says, uh-huh. What about 5? Uh-oh, trouble. Remember, the ambiguous case, right? You can have this triangle with a 90. You can have this triangle with a big guy. Those aren't ambiguous. It has to be that or that. But sometimes you have this triangle. Maybe there or maybe there. That's the one we have to worry about. Which of these applies to this? And that is, of course, when A, or I lie, when this side, whatever it may be, is longer than this, but shorter than this. So you might have to check them all unless you know. Well, it's real easy to check the obtuse ones, yeah? Because if angle D is 112 and E is 110 and F is 65, 110, 65, that would make this big F, that would make that big E, right? Is this, how many triangles can that be? It can only be the one. ABC, 108. D is now 108. E is 52. And F is 15. Well, if that's a triangle, then 108 and 52 is 160, yes? So this would have to be 20, yes? Right? 15. Is that possible? Yay or nay? So how do you go about doing this? Do you have to check them all? So I have A's and I have C's are my two choices, right? Well, if it's B, C. Angle A is 16, B is 12, C is 5, right? Everyone agree? Okay. So, would that be possible? Well, the only way to check is to have an angle, yes? So you would find an angle here using what? What's the only way to find an angle? Cosine law, you would find an angle and you would check with sine, yes? So you would find this angle, and then 5 sine A would be Q, yeah? And if this is 16 across from A, then this could be 5, 12. 16 is way longer than 5, right? Has to go out here. Okay, Myers, whatever you say, I'm going to make this 6. I'm going to make this 12 and this 5. 16 is still longer than 12, yeah? So it's got to go way out here. It can't be this one. So it cannot be A. A can only be the big triangle. So let's check C. Angle B is 35. A is 27. And the other side of B is 21. So this, Q, would be 27 sine 35, which you could check with your calculator is what? $15? So that's 15, right? The other side is 21. Is 21 longer than 15? Is it shorter than 27? So it could go there or there. So it was C for the correct answer here. Number 6. It's not multiple choice, so you got to actually draw it out. 2b, but cos is positive, right? So if cos is positive, it has to be over here, yes? So I got to be out here 2, and then I'm either up there at b or down there at negative b, yes? If cos is 1 root 10, and tan is negative, so can it be here? No. Has to be here, right? So this is the triangle I am dealing with. Cos is 1 over root 10. Well, I know this is 2, don't I? Right? But I need cos to be 1 over root 10. So 1 over root 10 has to equal 2 over what? 2 root 10, right? Everyone agree? But do we even need that? This is x over hypotenuse, right? Okay, so this is 2 root 10. How do I find this distance? What do I use with that shape? Pythagoras, right? 2 root 10 squared minus 4 has to equal b, right? 2 root 10 times 2 root 10 is 4, which is 4 times 10, which is 40, right? Minus 4 is what? 36 equals b squared. So what does b equal? 6, but it has to be negative 6 because it dropped down there. Yeah? Now, number 7, the other class needed all drawn out for them. Do you? Okay. Here is Oak Bay. Agreed? No, I lie. We're starting from Ross Bay. Agreed? Oak Bay, the boat will be red. The boat leaves Ross Bay, then sails to Oak Bay, right? So, Oak Bay is not north 57 degrees east. Where would north of Ross Bay be on a drawing? Straight up. Is Oak Bay straight north? No. Where is it? That's straight north. Where's Oak Bay? 57 degrees. In which direction? On this drawing. To the right. So Oak Bay is really over here, right? That is the direction to Oak Bay, yes? This is the 57. Cool? Everyone agree? All right. And then this would be straight east, yes? All right. So, oops, I should have drawn that more down here, right? Because I went 57 away. I went past halfway, right? So there's the 57. Everybody cool? The sailboat leaves north, but not north. How far did the sailboat go? 79. So if that's 57, the sailboat went out over here, yeah? This is how far? 79. This is how far? So what is this? 22. The boat sailed 1.9 km. Then the sailboat turned and traveled 1.1 to Oak Bay. There's your triangle. And what are you going to use? Starts with an S, ends with a W, has Ein Law in the middle of it. Sine Law. Good job, everyone. Well, you've been in my class long enough. You need to punctuate your funny jokes. Then everybody knows. See, Zach, when you've taught as long as I have, you wouldn't be surprised to have a kid say, couldn't use town law? There's no such thing. Oh. Sorry. I have to go back to tweeting. Yeah, that kid bugs me too. All right. So we're good with that. So obviously the distance from Oak Bay to Ross Bay is right here, yes? So that is x. So if this is 22, we know that sine 22 over 1.1 equals sine y over 1.9. So 1.9 sine 22 divided by 1.1 equals y. And then once we have that, we know this value, and then we sine law for that. Okay? I'm not going to do it all because that's all calculator work. You should be able to figure that out on your own, yes? Once you have the drawing. Number 8. Number 8, because it is sine 30, you can do it in your head, can't you? Because the sine of 30 is what? 1/2, right? So we draw it. A is 30. B is 16. 16 times 1/2. This is 8, right? Is A longer than 8? Is it shorter than 16? So how many triangles could I have? 2. I could have 16, 30, and that one. Or I could have 16, 30, and that one. Right? This being 10, or this being 10. And then, of course, you would do sine and cos law to find the other missing sides. Number 9. My man Rudy is 20 feet away. He's got to shoot this puck, yes? Within what angle must he fire the puck to have a hope of scoring goal? We just need this angle here, don't we? Cos law, yes? So what do I make this R? Little c.
Oh, sorry, I wasn't even paying attention.
Big C, and then I run it through Cosine Law. What do I have to remember to do at the end? Shift cos. What about number 10? PQR. There's P, it's 56. Across is 10, Q is 12. So there's Q, right? Sketch it. 12, this is 12 sine 56. What is that? If you did the question, you should just have to look at your work. What's 12 sine 56? If you didn't do the question, why aren't I hearing calculators ticking? 84?
Wait, hold on. Wait, hold on. I didn't hear 12 sine 56.
12 times sine 56.
Oh, I did the whole thing.
What is it? What? 9.9. This side, P is 10. Is 10 slightly more than 9.9? So, I can be here or here. Now, I got to check that. 12 sine 56 is, yes, 9.9.
Where's the trust? Yeah.
Well, it's an odd question that they made this 10, right? Because the answer was 9.9, and all you would round it up to 10. I don't like that question, because technically it's there or there, right?
I understood it as like drawing it and like solving all the sides, but like since Q is also like an altitude, they like took it as like a side too.
Well, Q is a side, 12.
Yeah, but it's just like I got confused.
Do people need to see 11? It's not that tricky, because what do you do with this green triangle? You got to do Cosine Law there, right? If you can get this theta, right? Then you can find this angle right here, red theta, because it's 180, right? And then you will use that over here with Cosine Law to find AC. A great many of you forget that stuff, right? You forget stuff you already know. Number 12, are people happy? 12 is drawn right there. Are we okay with it? Do I really need to go over it? Okay. 13. 13 caused the other class some trouble. Do I need to talk about it? Okay. Well, explain using examples how to determine all the angles when you're given a reference angle. Right? Okay, so I'm going to draw 4 terminal arms. Agreed? Okay. Where does the reference angle live? Between the terminal and an x-axis, yes? So if I know that reference angle, do I know that reference angle? Theta reference. How do I find theta? 180 minus theta reference. Okay. How do I find theta? Plus theta reference. How do I find theta? 360 minus reference angle. Is that explained? With an example? So why did you guys need to see it? Okay. Do 14 really cause trouble with the other class? Because they were all able to draw it. Right? They all said this is 70, this is 70, this is 70, this is 70. They all said these are 90, right? At the bases. Those are all 90, right? And the pitcher's mound, they said, was 50 away. And they said, yeah, but okay, Myers, if that's 50, and this is 45, and this is 45, then this has to be 50. What's the assumption they made that is wrong? That this pitcher's mound is halfway to second base. Is it? You don't know. It's 50 from home. We don't know how far it is to here, right? This is 50. Yeah? How long is this side? 70. This is 45 for sure. So what are we going to use to find this distance? Angle, side, angle, side. What do we use? Cosine law. I even gave you that on a piece of paper. I actually said when to use cosine law. It's right here. Cos law, side angle side. So, what do you make this? Little c, and then you solve for it. Oakley dokley. Oakley dokley. 15, you should be able to do 15. When do we use sine law? Angle and its opposite side. When do you use cos law? Sine angle side or side, side, side. A better thing, when you use sine law, when you have a pair. When you use cos law, every other time. Right? 16. The drawings are right there. Do we need to? I'm willing to. Oh, we're good? Okay, and 17. North Shore Search and Rescue. A lot of kids in the other class are like, oh, I'm no good at the direction ones. Is there any direction in this one? No, they leave their starting point, yes? There's start. Where does Team B walk? Or Team A, Alpha Group? They walk 3.8 kilometers. What direction? Straight east. 3.8, yes? Where does B walk? At an angle 129 degrees away. So B walks over this way, yeah? What does that make this? 129 degrees. Here's B. Do we know how far B walked? No, but they lost contact, didn't they? And they lose contact when the distance between them is what? 6.2. What do you do? Starts with an S, ends with a W, has Ein law in the middle of it. Sine law. Sine law will find this angle. It will get me green theta. Then I use green theta to find that side. Yeah, yeah? Yeah, yeah, yeah? Yeah, yeah, yeah. Is everybody ready? You will have your test on Monday, Lundi, Moon's Day. That's why Monday, that's where it got the name. It's the Moon Day. And in French, moon is la lune.
Wow.
Lundi.
What about the other days of the week?
Well, in English, the other days of the week are named after, the weekdays are named after Roman gods. And Saturday is named after Saturn. Or no, sorry. The weekdays are named after Norse gods. Tuesday is T-I-W, that god's day. Wednesday is Woden's Day, which was Odin, the king of the gods. Or as you guys know him, Anthony Hopkins from Avengers. And Thursday is Thor's Day, as you guys know him, Chris Helmsworth. Friday is Freya's Day, who is another one of Odin's daughters. I don't think she's in the Marvel universe at all. Saturday is Roman Saturn's Day. What?
Is it Freya Thor's mother? I feel like they did that in the Avengers, didn't they?
I don't remember who Freya is. I'm not up on my Norse gods.
Yeah,
Maybe.
wouldn't it be Thor?
Maybe it's Thor's mother. I don't know. And Sunday is Christian. Son. Christ. Son of God. Son's Day.
Oh, that's what they were all named?
Yes. In French, it's different. right? Lundi is Moon's Day. I don't know what Mardi is.
I have to go, coach. My year ones are next door.
I'll crack that whip.
Yeah. I told them they could come to the game at 2:10.
2:10. All right.
All right. Want your door shut? Or should I leave it?
No, leave it open so Madison can rat out any of those clowns that leave. Right, Madison? Yeah. Just go. I don't care. No, okay. None of them are biological mothers of any of them.
I know. I'm reading off what it says.
Freya is Thor's mother?
Yeah.
Okay.
Yeah, she was in the
Stepmother.
Okay.
I'm just saying.
I read a series of books set in our world, but in our world, every religion is real. Every god exists. It's all true. The dark elves of Niflheim exist. They're bad dudes in this book I read. They're also bad dudes in the Marvel Universe. Quite a bit of the Marvel Universe, quite a bit of this guy's series of books borrows from the Marvel Universe. But in these books, Thor is a real dink. Yeah. And everybody, all the gods across the world hate Thor. Doesn't matter where they're from. One of the main characters in this series of books is a Finnish god of thunder. And he's always bitching about how horrible Thor is. And the main character in the books I read, this series, actually kills Thor. I know, it causes much trouble. It brings about Ragnarok, actually. The only gods in these books that are actually immortal are the Greek and Roman gods. When I say everyone, I mean everyone. Jesus is a hippie that shows up in Arizona wearing sandals and ponchos. The book, it's a 9-book series called The Iron Druid. If you are at all into the Marvel universe, you should do yourself a favor and read the Iron Druid books. They're awesome. Huh?
Not that much.
Not enough to read 9 novels?
I'm not against reading. I'm just not.
I understand. You're not that invested. But if you have some spare time, I highly recommend the Iron Druid series. Anyways, it's 1:40. What? Hell, you can have them back. I don't care. Nobody else cares. Let's go over the cumulatives for all the people that are here, but I won't record it.